99. So you guys are going to tell me all the exponent laws that you remember from grade 10. Yes? Okay, first of all, this whole thing here is called a power. I'm not going to test you on that. The little number floating in the air is called the exponent, which you probably knew. And the number at the bottom is called the base. In other words, if I have 4 squared, the exponent is 2, the base is 4. All right. If you are multiplying terms that have the same base, what do you do with the exponents? Add them, yes. So it's x to the m plus n. If you are dividing, what do you do with the exponents? Subtract them. M minus n. If you have an exponent raised to an exponent, this bit right here, what do you do with the exponents? Multiply them. So it's x to the m times n. And if you have 2 terms inside brackets, all raised to an exponent, where does that exponent go to? Just like when you have a number outside the brackets, it goes to everything inside the brackets. So it's x to the m, y to the m. It's okay if you don't remember all these because we're going to practice them. If you have 2 terms that are being divided, all raised to an exponent, same rule applies. X to the m over y to the m. If you have a negative exponent, we talked about this last chapter, briefly. What does that mean? How do you make it positive? X to the negative m, how do I make the m positive? Flip it. So it's 1 over x to the power of m. And then that was grade 10. In grade 11, you looked at fractional exponents. So if I had x to the power of a half, what did that represent? What sort of operation? Square root of x, right? Because the number outside here is like really a 2. Is this ringing any bells? Hopefully. Barely. If I have x to the power of a third, what operation am I doing? Cube rooting it, exactly. So what does the bottom number tell you? What the radical is, we would say. So if it's x to the m over n, the n will tell you what root you were taking. So this is going to be the nth root of x. What do you think the m tells you? Sorry? Yeah, so it's like the power, just like a regular power. So it's to the power of x to the m. Or you can pull that m to the outside and do it afterwards. So it's the nth root of x all to the power of m. So just, if that was a 4/3, it'd be the cube root of x to the power of 4. That's all. That's the one everybody forgets. But we're going to practice some stuff right here. So 1/2 y to the 6, we're going to write everything without brackets and positive exponents. How do I make the y to the power of -6 positive? Where do I put it? Go for it. I picked that up. I didn't really pick it up, but all right. Back to whatever page this is. 199. Okay. So we're gonna simplify these with no brackets and positive exponents. So how do I make the -6 on the y positive? 199. Sorry? Put it in the denominator. So if you just write it as 1 over 2y to the power of 6. Done. Okay. How am I going to make the x positive and the y positive in their exponents? You can flip them. So if it's negative in the denominator, to make it positive, just flip it up. So you can flip the y up, and the x can flip down. Do I need to flip the 5? No, because the exponent on the 5 is positive. It's a 1. So this will simplify to 5y squared over x cubed. All right, bunch of brackets here, so we need to clear all them out. So we're multiplying. 4 times 2 is 8. X cubed times x to the -4. What do you do with the exponents? Add them. What's 3 plus -4? -1. So we're just going to write x to the -1. We'll clear up the negatives at the end. Y times y squared is y to the power of 3, because this one has an exponent of 1, so you just add them. Okay, how do I make the -1 positive? Drop it down, right? So 8y cubed over x. I could write to the power of 1, but you don't need to. Okay, this gong show. 24 m5p -3 q4 over -4 m4p2 q -2. Simplify it first. What's 24 divided by -4? -6. m5 over m4. What do you do with the exponents when you're dividing? 5 minus 4 is 1. P -3 over P2. What do I do with the exponents? Subtract. -3 minus 2 is -5. Q4 over Q -2. Q6, because it's minus and negative, right? 4 minus -2 is Q to the power of 6. All right, what do I need to flip down to make it positive? The P, right? Not the -6. Right? You can have a negative number, you just can't have negative exponents. That's what they want in this one. So it just becomes -6 m q to the power of 6 over p to the power of 5. E, 3x squared y cubed, all raised to the third power. Where does that power of 3 go? Everything. So that means it's 3 cubed. What do I do? I'm just going to deal with the x squared right away. What do you do when you have an exponent in brackets raised to another exponent? What do you do with those exponents? Multiply them. So it's x to the power of y to the power of. What's 3 cubed? 27. So it's 27x cubed, y9. Is that okay? Okay. 12b to the negative 1/2 over 3b. 12 divided by 3, let's deal with that. 4. Now, what do I do with the exponents? You want to put the b to the 1/2 in the bottom? You can, but what do you do with the exponents when you're dividing? Subtract them, right? So we're really just going b, I'm just going to do this off to the side, b to the 1/2 minus 1, right? Because this b has a 1 there, right? So what's negative 1/2 minus 1? I'll give you 2 ways to do this. You can do it the fractional way. So remember, if you're subtracting fractions, you need a common denominator. So the 1 would be 2 over 2. When you're subtracting, what numbers do you subtract? What numbers stay the same and which numbers actually you do the operation on? Top changes. So negative 1 minus 2 is negative 3, and the denominator stays the same. So it's b to the negative 3/2. Or, if you really, really want to, you could do it as a decimal. Essentially, that's what you're doing, right? Negative 1/2 is negative 0.5. So it's negative 1.5, which is the same as b to the negative 3/2. I'll think less of you if you do it as decimals, but you probably don't care. I'm joking. I don't care which way you do it. Okay, so this is our answer. Or if you wanted b to the negative 1.5, we have to make it positive. So what flips down? Just the b. Final answer is 4 over b to the 3/2, or 4 over b to the 1.5. But this is why fractions are better. Well, there's a multitude of reasons. What does this mean? B to the power of 3/2 mean in terms of radicals? It's the square root of b all cubed, right? The bottom tells you what root, so it's like square root of b, and you can put the 3 in there if you really want. Okay, so that's another way to write it. You could write it like that if you really wanted to. Oh. Okay. Going once, going twice. Are we okay? Okay. All right. Simplify, writing with positive exponents. Okay. The reason most kids don't like students, sorry, you're not kids, young adults. The reason most young adults don't like exponents are, one, you have to know all the rules, but two, there's a multitude of ways to do every single question. Okay. So there's different ways to get to the same answer. On this one, what do you want to do? We have to simplify this. No, everything has to be positive exponents. So what do we want to do first? Put the negative 3 in. We can go 4 to the negative 3, x to the negative 3, y to the what? Positive 6, right? Because you're multiplying. Now we have to get rid of everything that has a negative exponent. So what do we do? Which ones? The 4 and the x. So then I get y to the 6 over 4 cubed x cubed. 4 cubed, anybody know it? What's 4 squared? Times 4. 64, there you go. So it's 6, y to the 6 over 64 x cubed. All right, b. This fraction raised to the negative 2. Now again, multitude of ways to do it. You could put the -2 into everything, but if I see a -2 with a fraction, like the whole thing, I flip the fraction. So I just go like that to make that 2 on the outside negative. Then I put the 2 in. So it goes to everything. 4 to the power of 2. 16 y to the -4 over 3 to the power of 2. 9 x to the power of 6. What's the only thing I have to do now? Drop the y. So I get 16, 9, x to the 6, y to the 4. You could have done this, just to show you. You could have put the -2 in. I don't have to write this down. And then, obviously, this 4 to the -2 flips up. These two top ones flip down, so you get 4 squared over 3 squared, x to the 6, y to the 4. 4 squared is 16, 3 squared is 9. So you get the same answer. It's whatever you prefer. I don't care. Okay? Totally up to you, how you do it. Okay, without using a calculator, determine the exact value of the following. Verify with, yeah, we're not verifying. So verify. All right, 2 to the -3. What does that -3 cause you to happen? Flip it, right? And remember, that's like over 1. So it would just become 1 over 2 cubed. Anybody know what 2 cubed is? 8. So it's 1/8. 2 to the -3 is the same as 1/8. B, 81 to the 3/4. As soon as you see a fraction, what are you doing? Some sort of radical or root, whatever you want to call it. What root are we doing on this one? 4th root of 81. And I usually like to cube it after. Anybody know what the 4th root of 81 is? I.e., what number do you multiply by itself 4 times? Just told you the answer. To get to 81. 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the answer is 3 on the inside there. What's 3 cubed? 27. Anything to the 0 power is 1. Yes. Do you guys know why? Has anybody shown you why? Sorry? I explained it, yes. So this is why. You don't have to write this down. Is that the same? Right? 1 minus 1 is 0, right? If you're subtracting exponents, that means you're dividing, right? Everybody agree with that? What's any number divided by itself? 1. There you go. That's why. Boom. All right. 16 to the -1/2. So the negative, what does that cause you to do? Flip it. Power of a half means we are square rooting it, right? Square root of 16. So the answer is 1. Whoops. Okay. This would be the point I assigned 1 to 3, but I'm not going to because we have to burn through this. So you're going to have more work to do tonight. Sorry. Changing the base. Okay. exponent for now. And we just focus on the 9. How can I write 9 as a power of 3? i.e., 3 to what power is 9? Squared. So 3 to the power of 2. So I can rewrite the 9 as 3 to the power of 2. And you have to remember the 2x is there. Everybody okay with that? Okay. What do I do with these exponents, the 2 and the 2x? You multiply them. So this becomes 3 to the 4x. So 9 to the power of 2x is the same as 3 to the power of 4x. All right, B. 125 to base 5. So ignore the 2 minus x as the exponent. 5 to what power is 125? 3. So you bracket it, and the 2 minus x is sitting there. And you think back to math 10, and you go, okay, I'm multiplying these two things. So that 3 has to be multiplied to both 2 and negative x. The distributive principle. So this becomes 5 to the power of 6 minus 3x. All right. 8 times 16 to the power of x. That whole expression, I want to change to base 2, a single term. So deal with each one separately. You cannot multiply the 8 and the 16. Okay? The reason you can't is because the 16 has an exponent on it. If the 16 was just to the power of 1, you could do that. Because it's got a variable as exponent, you can't multiply 8 and 16. So let's change 8 to base 2. 2 to what power is 8? 3. 16 to base 2. 2 to what power is 16? 4. And remember that the 16 has an x there. Now I can combine these because the bases are the same. The bases are the same. Multiplying. What do you do with the exponents? Add them. So it becomes 2 to the power of 3 plus 4x. Because you can't add the 3 and the 4x because they're not like terms. Is that okay? All right. 1 over 512 to the power of 3x. Okay, so make it base 2. So first of all, fraction. So after all the heads explode, what do we do then? We're not changing it to a fraction, right? So how do I take this fraction and make it so that it's technical fraction, but the 1 is the bottom of the 5. You make it 512 to the power of negative 3x. Same thing, right? Now I need to make 512 base 2. You can use your calculator. 2 to what power is 512? Just guesstimate. Don't just go 2 times 2 times 2. Well, you can do it that way. It can take you a while. Just try a number. Try 10. It's 2 to the power of 10. Anybody got the answer yet? It's 9. 2 to the power of 9. 2 to the power of 10 is 1024. Half of that is 512. Okay? So it's 2 to the power of 9. but there's a negative 3x there. What do you do with those exponents? You don't multiply them, right? It's an exponent raised to an exponent. You multiply. So it's 2 to the negative 27x. 2 to the negative 27x is the same as 1 over 512 to the power of 3x. You guys are loving this right now, aren't you? Just wrote a test and now you're doing fractional exponents. Best Monday ever. Nothing. Okay, somewhat of the last one. Second to last. Well, we're not. So. 16 over 81 to the power of x plus 5. We're changing it to base 2 over 3. So the first thing you have to ask yourself is, since 16 is up top, can I make 16 in the base 2? Yes, that's a good thing. If it was flipped, you'd have to flip it. Okay? If it was 81 over 16, you have to flip it and put a negative. All right, so, and can 81 be made base 3? We just did that earlier, right? Yeah, another question, thank you. So, I go, okay, 2 over 3. Actually, all right, 2 over 3. 2 to what power is 16? 4. 3 to what power is 81? They have to match. If they don't match, we've got an issue. It's a different type of question, okay? So they have to match. If they don't match, either you've done something wrong, not likely, I've screwed up the question, highly likely, or it's just a bonkers question that you don't know how to answer, unlikely, okay? So probably I screwed up the question. So 2 to the 4 over 3 to the 4, all raised to the x plus 5. That makes perfect sense. All right, what can I do? How can I rewrite this as 2/3? I can just say 2/3 all to the 4. Is that the same thing? Looking for head nod confirmation here. And that 4 gets multiplied by x plus 5, which if you dump 4 in, you get 4x plus 20. Okay, we'll just do the last bit and then we're done. I'm not going to do lesson 2 today. I feel like we're just blowing past stuff here. All right, we're going to skip down. We're going to skip all this stuff. And we're going to skip right to the bottom here. Solve for x in the following. So this is algebra, okay? And you've done this. It's just been tweaked so that it looks like something you've never done before. So if I gave you x squared and said it equals 25, how would you solve for x? Don't tell me what the answer is. Tell me how you would solve for x. You would square root both sides, right? And you would get what? That's half the answer. Plus or minus 5. Okay? That's what you would do. If I gave you x cubed and said it equals 27, what would you do? You'd cube root both sides, right? So you would cube root both sides. And you get x equal to 3. Okay. What you're actually doing is, so we'll take this one here. X squared is equal to 25. Here we square root it. Okay. What if I did this? Square rooting in terms of a fractional exponent. 1/2, exactly. So what you're actually doing is you're raising each side to the 1/2 power. Okay? And that's why what do you do with these exponents? Multiply. Right? You multiply these. What's 2 times 1/2? 1, right? Thank you, Rory, for putting up the 1, not the other finger. 2 times 1/2 is 1, right? Correct? Okay, so we write x. And then we know that's the square root, and that gives us plus or minus 5. So what you're actually doing is you're raising side, the math word, the reciprocal of the exponent. What is reciprocal? Sorry? Yeah, it's basically the flip fraction. That's 2. I could write it like that, right? Nobody would ever do that, but you could write it like that. So what you do is you raise each side, because what you do to one side, you have to do the other side, just like they taught you in grade 4, 5, I don't know what grade you went on is. Same thing for this. You just raise it to the reciprocal exponents. Those all go away, and you're just left with x. This is a fractional exponent, which means the square root. Take the square root of it, get your answer. You do the same thing if it's weird looking. Sorry, that's probably not correct to say in today's world. If it's special, that's probably worse. If it looks different, I don't know. Anyway, so what is the reciprocal exponent of -4/3? Use the -2. What's the reciprocal of 4/3? 3/4. Put a negative in front of it as well. That's what I mean. So you're going to go x to -4/3. You're going to raise it to the -3/4. And what you do to one side, you have to do to the other side. So 81 to -3/4. All right. What happens to everything that's on the x side? What are you left with? Just x. All this stuff cancels. That -4 cancels that cancels that, and you get x. Okay, now this stuff on the right-hand side is what we did in the previous pages. What does the negative tell you? I'm going to fall over. Flip it over. What does the 4 tell you? Let's zoom it right in. That's the what? That's our root. We're doing 1 over the 4th root of 81, all cubed. What's the 4th root of 81? What number multiplied by itself 4 times equals 81? 3. So I get 1 over 3 cubed. What's 3 cubed? So it's 127. Okay. So now it's a little harder. Now what about this thing? It looks different. Difficult? I don't know what I'm supposed to say. Okay. Forget all this junk. We don't care about this right now. All I care about is this. How do I get rid of this? Raise each side to the power of 2/3. So 2 over 3, 2 over 3. Oh, it gets all weird looking when you're really zooming. What happens to this stuff? Goes all away, right? Turns into 1, power of 1. 2's cancel, 3's cancel. So I'm just left with 3x minus 5 is equal to. All right, peoples. 27 to the power of 2/3. What root are we doing? Third. Yes. The third root of 27. Which is what? 3, all raised to the power of 2, which is 9. Now I got 3x minus 5 is equal to 9. Does everybody follow that? This is important. I know I'm like acting like an idiot, but that's just my natural state. Okay. What do I do now? Now all the grade 12 math, grade 11 math, grade 10 math is gone. Now we're floated back into grade 9 math. Like, I don't know when you learn algebra. Grade 8, 7, whatever grade it is, grade 7. Now it's just algebra. What do I do with this 5? You add it to the other side. 9 and 5 is 14. How do I get rid of 3? Divide it. So what's my answer? 14 over 3. Just walk away from the fraction. Put your pencil down and walk away. Don't turn it into a decimal. You turn it into a decimal, I'm going to have to throw stuff at you. Probably not the best thing, all right? I'm going to get fired. You're not going to have a math 12 teacher. You're going to fail. You're going to end up on the streets. It's a whole thing that's going to happen, all right? Don't write decimals, all right? Are there any questions? Other than why are you an idiot? Okay, what do you do if you have a weird exponent and it's some sort of equation? Raise each side to the reciprocal. Okay. What questions are we doing here?